When it works, when it is not working, I am not understanding.
Okay, sir.
Okay, sir.
So here I started a recording. Then here it is PC hardware. Okay, so this is the a block diagram. You can see here it is a block diagram. Is a traditional block diagram. CPU, memory, input, output, CPU, memory, input, output. You give input to the CPU, process it, and store if required in a memory or retrieve data or instructions from memory. Okay, so for a processing purpose, once completed, put it in a output device. A standard input device is keyboard, standard output device is monitor. CPU, output device, input device, and it is a memory. Okay, three things. Okay, next one. Okay, and next one, it is okay, so these are the basic block diagram. So first, next one is different components of a computer. Guys, this is the box, we call it as a cabinet. Normally, we are going to traditional computers. We have a laptops now, and we have a desktops also. Laptop and desktops are there. Laptops and desktops. Okay, so laptops, of course, we have seen, and desktops also there. Also, the desktops also there. So here is my desktop. It is like a box. We call it as a cabinet. A lot of people call this one as a CPU, but it is not a CPU, guys. It is a cabinet. This cabinet, internally some components are there. Externally, some components we are connecting through it. Okay, so you can see here it is. There is a CPU, central processing unit, is nothing but our processor, or a chip. It is a processor chip, not box. Processor is a chip. Okay, CPU, central processing unit. Next, RAM, random access memory. What is RAM? Random access memory. RAM is there, ROM is there. Generally, when you see a laptop or desktop, and where is the ROM kind of stuff? It is nothing but your BIOS chip or UEFI chip. And there is a motherboard. And all our devices we are connecting to motherboard only. Either on motherboard or to motherboard we are connecting. Okay, hard disk, SSDs we are using nowadays. SSDs, hard disk, CD, DVD, SMPS. These are all main components of a computer, right? So floppy disk is now people are not using. It is not available either. It is a desktop or laptop kind. Okay. Next one, we are connecting to our computer or desktop or a laptop. Connecting like this, desktop and laptop combination. I put it like a keyboard. Without a keyboard, how we cannot give instructions generally is a traditional way. So standard input device, keyboard. Mouse is a pointer device. You want to highlight something, you want to select something, or you want to point out something, we can use the mouse. In the olden days, the people do a challenging type. I use my mouse. Without mouse, I will do everything with my keyboard. Of course, you can do it, but it is a waste of time. So use both keyboard and mouse. So then it is we can use more efficient. Okay, more easy. Okay, that is always better. Of course, you have a monitor to see the content on the screen, right? Without a monitor, we don't know what is going on. Printers and scanners. Of course, it is not compulsory device, but only it's a printer and scanner kind of stuff. Convert soft copy to hard copy to soft copy. So printer, you have a document, you want in a paper, then we take a print, right? So data in your system called a soft copy, and once you taken a printout, the data is on the paper, that is called a hard copy. Scanner is a converts hard copy. For example, you have a document or a picture, you scan it and store in your system, that is called a soft copy, right? So that is the printer and scanners. Touchpads, usually laptops having a touchpads too, so for a function of mouse, for a mouse functioning. Touch screens, nowadays we are having mobile tablets, including laptops, two-in-one laptops, um, all-in-one desktops, two-in-one laptops, all-in-one desktops, okay, and also touchscreen laptops, Surface Pros. These are all comes under. We have a touchscreen to give input. Both, yeah, like instead of mouse and all, we can simply use by using touch. Mic and speakers. Mic and speakers. So you can connect a mic, right? So I'm speaking to the mic. Of course, I'm not physically connected it, but built in my laptop, I have a mic. So if it is a desktop, you have to connect a mic to speak and send your voice signal to the computer and speaker. So any audio signal you can able to hear, speaker is useful. Card readers, if you have a SD cards kind of stuff, memory cards, so that's the card readers useful. Bluetooth devices to connect any Bluetooth related devices like a headphones kind of stuff, right? Bluetooth connectivity devices, Bluetooth monitors, Bluetooth projectors kind of stuff. So external hard disk to store huge amount of data, which is you are not wanted to store in your computer. Don't require to store your computer because no quick requirement. For example, I have some movies. I don't require to watch every day. Everyday usage is not there. I have some applications, everyday usage is not there. I have some operating system images I downloaded, but everyday usage is not there. So better to keep it in an external hard disk, so then my system will get a more free space. Okay? That is the purpose of each and every device. Of course, first of all, we are going to learn about the CPU, RAM, ROM, BIOS, motherboard, hard disk, and all. So today only we started, so we'll see. A message. Vipin. Okay, guys. CPU, Central Processing Unit. CPU, Central Processing Unit. It is a brain of our computer. Semi-conductor device. Guys, some people may not know about all these things. Whether you know already or don't know, please listen carefully. You have a doubt, you can ask me, no problem. And of course, also respond sometimes. That is also important. So CPU is the brain of computer, semiconductor device. It contains a complete CPU. So sorry, it is a single chip kind of stuff. Okay. It perform arithmetic and logical function. All processing of a computer is taken care by your CPU only. Remaining having other functionalities which but main processing by your CPU only. There are a lot of details about a CPU, but some we will discuss here. Here it is. When you see a CPU, so when you check your system configuration, when you see about a CPU, few things are we can able to see. What is the speed of a processor? Already we know how to check the system configuration, right? So you will see it is. This is my 2.6 gigahertz processor. It's the speed of the processor. Number of cores 2, number of logical processors are 4, cache memory and virtualization. So this is the speed. Cache memory, number of cores, virtualization technology, and number of threads kind of stuff also we can see here. And is it a processor is 32-bit or 64-bit processor? Your system is 32-bit system means your processor is 32-bit. Of course, your operating system means your operating system is also 32-bit only. Your processor is 64-bit, so it can execute 64-bit size of instruction, guys. What is the 32-bit? What is 64-bit? That confusion is also there. You know, the first processor from Intel 4004, it is 4-bit processor. Then it is released 8-bit processor, 16-bit processor, 32-bit processor, and 64. Nowadays, maximum all processors are a 64-bit processors only. Difference is the instruction set, instruction, the processor is that size of bit number, like 32-bit processor having 32-bit instruction. It can execute 32-bit instruction, 32-bit data also. So 64-bit instructions can be executed by 64-bit processor only, cannot be executed by 32. Okay. So what is the advantage of using a higher bit compared to lower bit? Instruction length increases. Length of instruction is increases. It means more complex instructions I can able to give. Let's look at here. Nowadays, we can do a lot of wonders kind of stuff, right? Cloud computing, artificial intelligence, face recognitions, thumb impression, faster we can able to process and showing like a lot of apps we are using. Right? So each one will work based on the background instruction. Okay, background instruction, how to take input, how to do it, how to generate outcome. That is a base instructions are there. Lesser the complex means like a plus b is equal to some value, a value, b value, arithmetic. That is no complexity also. No complexity. Okay? Less complexity. But a very high complexity means like engineering mathematics. Lot of complexity is there, right? So like you have to find out something differences, integrations, trigonometry, complexity increases there. Okay? Tan A plus tan B, cos A plus cos B, sin A plus sin B. There is a complexity, right? Little complexity increase. I'm not talking that is a very complex. I'm saying it is complex than A plus B. Point is, larger the instruction size, the complex instructions we can have. Larger the data size increases, then complex data also we can able to. But so the length of the instruction size increases, data size increases, then required memory size also high. Required memory size is also high. What is required memory size? Like RAM and storage also required high. But you will get certain features. Guys, remember your processor is 32-bit, OS must be 32-bit, device drivers must be 32-bit, applications must be 32-bit. Same goes for 64-bit. 64-bit processor, drivers are 64, operating system is 64, and application also 64. Of course, there is a low bit compatibility is there. For example, you have a Windows 10 64, you can install 32-bit application also because of built-in above kind of feature. But not always it is suitable. Only in a certain cases, certain operating systems supported, but not for all operating system. In the common grounds, commonly 64 means 64 only. Okay. Of course, 64-bit processor having certain features like a virtualization technologies, multi-core processing, UEFI support, secure board, okay, device drivers, digital signature enforcement, few features are there. When you see an application or an operating system or certain representations, if it is a 32-bit, it shows like a 32-bit, 64-bit, or 32-bit, it shows as a 32-bit x86, i386, i586. Yes, x86 represent Intel 32-bit. 86 represent Intel. 86 represent Intel. x86, i386, i586 means Intel 32-bit. 86 represent Intel, not 32-bit. Some packages like our operating system or some indication it is a 64-bit type. Means it shows like it is a 64-bit, written like a 64-bit or x64, just for understanding x64. No, it meaning is nothing, just for our understanding it is a 64. AMD 64, x86 underscore 64. AMD 64 means AMD type processor. In a processor, we have a manufacturing lot of processors are there. Out of that one, for our laptops and desktops, Intel AMD are more competition. AMD 64, Intel 64. Intel 64 represent either Intel 64 or x86 underscore 64. Already I told 86 represent Intel. x86 underscore 64 means Intel 64 bit. AMD 64. So any which way 64 is 64, 32 is 32. Yeah, not finished. Okay, that is a width. So 32-bit processor it is, 64-bit processor. What is the speed of the processor? Front side bus is tell about what is your RAM speed. How much RAM speed you should take it is tell by your front side bus only. Cache memories. So cache memory, the more the cache memory, better the processor. The cache memory is higher, the processor is much better. It's faster processing. Number of cores, number of logical processor means 2 core 4. 2, 4 means 2 logical core processors. So I will tell what is it is, guys. So get here simple. Earlier days we have a single processors. For a server purpose, that is not enough. So what they will do it, they have a one type of motherboards. So they can insert multiple processors, the different sockets. That's why it is giving a socket size also one. Normal systems we have one single socket. Servers motherboard may have a multiple sockets. Okay, so multiple processors you can insert it. So it improves the speed of processing. For desktop, we cannot do it. We have limited space, limited space on motherboard. And if you want to go for a multi-processor, like a server motherboard, so then it is become more costly for a regular user. Then what we are doing it, to use a single processor only. Later on days, people invented something like it's a sandwich type. Means first of all, single processor, single cache memory. Just remember. So data and instruction load into cache memory to your CPU. And CPU to cache memory to outside. Okay. So what they done, they take two processors like this, both are sandwiched. Now it is a common cache memory. This is the processor 1, this is processor 2. Okay, one cache memory, load the instructions, give it either 1 or a 2. So both are like this. So what happened? A process run by two processors. It speed up your process. So this is called a dual core. What is dual core? Two processors mixed with a shared cache memory called a dual core. Two processors sharing one single cache memory. Both are having a single unit. Unit is same means one socket, one processor only. Look like a one processor only, but it is a combination of two processors. This technology is still existing, like a Atom dual core processor, Pentium Gold processors. Now still dual core processor is there, guys. You want a processor, just you want a computer with a low cost price kind of stuff. Of course, you can go with this processor. Next one is people divide a processor into two parts. It's a single processor divided into two parts. This is called a core 0. This is a core 1. This is core to geo model. Core to geo model. Okay, that is called a core to geo. Next one is quad core processors. This is a quad core processor. Quad core means each processor is divided into two parts. Each processor is sorry. Quad core processor means one processor, four parts. Okay, octa core, one processor, eight parts. Next one is what is this logical processor? Logical processors are called hyperthreads. Now each core again having a double layer like this. This is core 0. Two layers are there. It means you feel like a 8 core processor. Sorry, 4 core processor. Here you feel like a 8 core processor. Means multitask is possible. What is the sorry, one more point I missed here. Okay, so I miss here. I will tell that point first of all. So this core processor means one processor divided into two parts. Okay, and having two caches separately. Each core having two. So it is instructions loading to cache, cache to core. Instruction loading to cache, cache to core. Means it is dual. Means two tasks we can do at a time with the same speed. Okay. This is also having same four cache memories. Cache is divided into four parts for each one having one, each core having a cache memory. So then instructions easily like multitasking is possible, and to speed up your process then you have a threading. So if you have a threading means it is a better processor, good speed. Means double time it will be can benefited. This is called a hyperthreading or a logical process. Okay, so those are the basic details of your CPU. And a small detail I want to tell guys. This is the heat sink. What is heat sink? What is heat sink? We'll see that one. I'll show you what is heat sink. It is a heat sink. You have a processor, guys. You have a processor on motherboard. Okay. So this is motherboard. Here is motherboard. This is the CPU socket, and here it is heat sink. Okay, this is the heat sink. Okay, you will put the heat sink on the processor. So what is the advantage of that one? Processor will get heat. Processor will get heat while it is working. Heat sink absorb the heat from the processor. Heat sink absorb the heat from processor and try to cool it by passing through it. And there is an exhaust fan on it. This fan will try to cool it. It's like you take out the heat from inside to outside. You don't blow the air to in. Take out the heat from inside to out. So like that it will maintain the temperature. And there is a heat sink paste on processor and heat sink or between your processor and heat sink. So this heat sink paste is absorb the heat from your processor and give it to your heat sink. Okay, so it make a more contact and it will provide a better cooling than without a heat sink paste. Okay, sorry. If you are compared to like if you are having a processor and heat sink, there will be always a small gap. So this will fill that gap and will give more heat, absorb the more heat from processor and give it to your heat sink. Okay. Yes, this is the laptop related. Can you see this is the in laptop? This side it is a processor on it. In a desktops we have a processor on processor heatsink. On heatsink there is a fan, but here it is not there. It is a processor. On processor there is a heatsink. It's try to absorb the heat from it, and there is a connected copper rod giving heat passes to this copper assembly, and this fan is trying to take out the heat from your laptop to outside. That's why guys, do not close these heat vents. Any air gaps laptops people use, they put a laptop on a bed, laptop on a lap. So what happened? The bed cloth, this kind of stuff is blocks the air vents. It blocks the air vents. Do not put your laptop on the surface which is blocking your bottom and four sides of the laptop because of there is a air vents. Please check the air vents also. So, and do not block these air vents. So let it get in cool. Okay? Even it is a overheated, not overheated, let it give some space. So then it will get heat. Otherwise you will get a power. That's a very simple. Guys, here is the point is you started a computer and it is working and it is restarted without generating any warning or without showing any error kind of stuff. It is restarted. So maybe one of the reason is on processor heatsink paste is gone. The heatsink is not sitting properly. Heatsink fan is not working. Okay, that is a possibility is there. Or entire heatsink become dust affected. Last time means almost like 3 years back it is. Okay, so what happened? One of the system for every 5-10 minutes, so it is getting overheated and restarted. So the guy given a complaint to me. I am also sitting next to that place only. So I open the cabinet and see there is a heat sink with full of dust in it. because of the dust, heat is unable to go out. So CPU is getting overheated. Okay? CPU heat is not going out. It means CPU is getting overheated. In order to protect your system from getting overheated, so what it will do, system automatically try to restart itself without showing any warning. Okay? Your computer check the temperature of your CPU. It crossing the limit means it restart your computer automatically. So if you face frequent restarts kind of stuff on any desktop, generally the heat sink is created by the first of all chin paste using properly sitting or not, fan is running or not, like that. Okay, so frequent restarts. Check this heat sink related kind of stuff. Okay, this is about your sorry about your CPU. Guys, understand up to here?
Yes, sir.
So next one is memories. Two type of memories, primary memory and secondary memory. Primary memory, you have a RAM and ROM. Secondary memory, hard disk, CD-ROM, floppy disk, like they're all secondary memory devices. Okay, floppy disk. Sorry, what are the primary memory? Floppy disk are not there now, so no problem. So what are the primary memories? RAM and ROM. What are the primary memories? RAM and random access memory, read-only memory. Okay, random access memory, read-only memory. So what is the RAM? RAM is a volatile memory. ROM is a non-volatile memory. What is the meaning of volatile memory? Volatile memory here is a temporary memory. Whenever the device is power off, data in the device will be gone. That type of memory, data in the memory device, okay, data will be gone automatically. That is called a volatile memory type. Non-volatile, it means even if you power off the device, data still remains in the device only. For example, you have a pen drive. You have a data in your pen drive. You connect, read it. You can disconnect, that's it. Still data is there in the pen drive. Okay. Next, RAM is a volatile type. It means when the power is off, data in the RAM automatically cleared. ROM, read-only memory, non-volatile memory, data won't be gone even if you turn off the power. Okay, of course, ROM is a chip on your motherboard, so it is having a fixed data in it. ROM having a fixed data in it, so which is given by manufacturer of that ROM only. It is not required to load any separate data and share that to another resources, not required. It is already instructions and data stored in this chip while manufacturing of a computer, generally and ROM chip. And what is RAM? Random access memory. Of course, volatile memory, temporary memory. When your power is off, data is gone in a. Of course, in the RAM, two types are there. So one is static RAM, second one is dynamic RAM. And static RAM is SRAM, dynamic RAM is DRAM. SRAM, cache memory, built inside of your CPU. DRAM is a dynamic RAM, SDRAM, DDR, DDR2, DDR3, DDR4, ECE, ECC RAM, EDO RAM, VRAM. These are different guys. Again, what is static RAM? SRAM is built based on a pure form of transistors. It means it is a much faster than a DRAM and it is costlier than a DRAM. Now it is cache memory. It is used as a cache memory. It is built inside your CPU. So CPU cache memory is nothing but a SRAM memory. DRAM memory, DRAM type of RAMs are DRAM means dynamic RAM. So DRAM is further developed into SDRAM, synchronous dynamic RAM. And this synchronous dynamic RAM further developed into DDR, double data rate. So these DDR2, DDR3, DDR4 are launched into the market, still DDR4, DDR5 in the market. So DDR5 also is Intel 12th generation processor supporting. That too few processors, not all processors. RAM is sizes are different, like different RAM sizes are there, guys. In MBs, GBs, TBs kind of stuff. Okay, like 8 GB RAM, 16 GB RAM, 32 GB RAM, 42 GB RAM, 4 GB RAM, 2 GB RAM. Generally, we are using these things generally in a computer. And each RAM having a certain megahertz frequency is there. It's a clock speed is also compulsory. 1333 megahertz, 2666 megahertz, 1600 megahertz, 2400 megahertz, 2400 megahertz, okay, 3200 megahertz, 3400 megahertz. These are speeds. So next one is different voltage levels are there. So low voltage, high voltage kind of stuff. Okay, so before you purchase a RAM or you want to replace a RAM or you want to add one more RAM, you have to check it with GPU compatibility because of CPU must be compatible with your RAM model. Size of the RAM, maximum size of the RAM, speed of the RAM compatibility also required. Better to check with you are already having some RAM on this same computer. You want to upgrade or add a RAM or replace the RAM, stick with the old RAM. So then maximum specifications will be you can easily matches. Okay, very simple. Motherboard and CPU, based on CPU and your motherboard, you have to choose which RAM is required. This is a small thing about RAM, guys. RAM has a different packages: deep, SIM, DIM, RIM, SODIM kind of. What is this SODIM? SODIM package type of RAMs are a laptop RAMs. So I will show you that one. These RAMs are look like a small. This is called as SODIM packages. So normal RAMs like this. These RAMs are desktop RAMs. These RAMs are laptop RAMs. So you can see this is a desktop RAM. This is laptop RAM. 2.66 inches, 5.25 inches RAMs. Desktop RAM and laptop. DIM packages, SODIM packages. Each RAM having a pin numbers. Each RAM having some pin numbers. Each RAM having some pin numbers and RAM slots. Guys, remember on motherboard. Motherboard is suitable for DDR4 particular RAM type only. Then is suitable for that type of RAM. Okay. If you want to put a DDR3 model or DDR5 model, cannot fit it. Okay. Okay, that is also there. Already told static RAM. Then this is the diagram of your memory kind of stuff, guys. You have a device, as I said in a first block diagram, input given to CPU, CPU to output device kind of stuff. Now, actually, CPU interact with RAM only via cache memory. So whenever you are connecting your devices like input devices like a keyboard, monitor, your mouse points, hard disk, everything is connected through I/O controller. I/O controller defines what are the devices, where it is located, where it is connected, to maintain entire that memory control and design the priorities also. So whenever you I/O controller receive instruction and data, give it to RAM, RAM give it to cache memory to CPU. CPU process it and give it to cache, cache to RAM, RAM to I/O controller. Okay, so there is a north bridge and south bridge between RAM and CPU. North bridge will operate south and south bridge RAM to other peripherals, devices, kind of stuff. So whatsoever it is, guys. I/O controller collects information, a request or anything and passes through the RAM to CPU. Okay. Next one is your ROM, read only access memory kind of stuff. Yeah, I will tell ROM and BIOS settings, motherboard and SMPS. Okay, in a single shot. Okay, now take a break, guys. Have a tea or coffee, don't sleep. Understand up to here, RAM and ROM. So ROM I will start. What is read only memory?